Characteristic and key feature of transition elements. Today's topic for discussion is transition element, transition series, properties of transition elements, electronic configuration, oxidation state. Now, what is transition elements? An element whose atom has a partially filled d subshell or which can give rise to cation with an incomplete d subshell. Transition elements. A brief introduction. Transition elements are characterized by preferentially filling of n-1d orbitals. Transition elements include elements of d block and f block of periodic table. They show properties that are transitional between highly electropositive s block element and highly electronegative p block elements. Transition elements act as a bridge between the highly metallic alkaline metal and alkaline earth metal on the left side of the periodic table and the non-metallic non-metal halogens and noble gases on the right side of the periodic table. Just you can see transition series, three series. First transition series, which is in fourth period, starting from scandium 21 to zinc 30. Second transition series belong to fifth period, starting from yttrium 39 to cadmium 48. Third transition series, sixth period, first element lanthanum 57 to mercury 80. In between this, there will be inner transition elements from 58 to 71. The C lanthanum 57 and actinium 89 are included in lanthanide and actinide series respectively. Just properties of transition elements. They have low ionization energy, they are electropositive, they have an oxidation state, positive oxidation state, they show variable oxidation states since there is a low energy gap between them. Very hard, highly metallic, high melting point, high boiling point, they show malleability, high electrical conductivity, high thermal conductivity. Now, when one of the peculiar property of transition element is formation of coordination compound with Lewis base, they are colored due to DD transition. They form paramagnetic compound because of the unpaired electron. They exhibit catalytic property. Now, general configuration of inner transition element is Ns2 n-1d1. That is d orbital first electron will be filled. Case of scandium 21 3d1 4s2. Ns2 n-1 d10. This is the last element. 3d10 4s2. Same way in fourth series and fifth series. Now, oxidation state. What is oxidation state? All of you know oxidation state is formal charge left on atom or ion. So, transition elements, aside from the first and last individual from the series, display various oxidation states. Now, why first and last? Scandium 321 has showing plus 3 oxidation state. Now, there are 3d1 and 4s2. So, suppose it leaves 3 electron, it becomes d0. 4s0, 3d0 shows plus 3. Similarly, zinc only plus 2 oxidation state. 3d10 is complete, 4s2 is full. So therefore, it shows only plus 2 oxidation state. They indicate variable valency in their compound. Some fundamental oxidation state of the transition series you can see in the table. One beautiful example I have shown you, scandium plus 3 oxidation state, titanium showing plus 2, plus 3, plus 4, vanadium showing plus 2, plus 3, plus 4, plus 5, chromium shows plus 2, plus 3, plus 4, plus 5, plus 6 oxidation state, manganese plus 2, plus 3, plus 4, plus 5, plus 6, and plus 7 oxidation state. So this yellow shade shows most frequently seen, and green shows less common. And beautifully, you can see there's a pyramid because of more unpaired of electrons. So manganese is, you can see, having 5 unpaired electron here. So the numbers of unpaired electrons are more. Therefore, you can see variable oxidation state from +2, +3, +4, +5, and +4, +6, and +7 oxidation states. For 4D series, from yttrium to cadmium, again you can see a pyramid is forming. Lanthanum to mercury for 5D series, again you can see these are all variable oxidation state. Now what the important point is +2 and +3 oxidation stage shows ionic characteristic, whereas the higher oxidation state shows covalent characteristic. Iron shows +2 and +3 oxidation state, while ruthenium and osmium shows +4, +6, and +8 oxidation state, because 4D and 5D become progressively more penetrating, and distinction between Ns and N-1 d orbital becomes smaller with increase in effective nuclear charge. Now here is unusual oxidation state and their stability in aqueous medium. As you know, high charge to size ratio does not permit the existence of iron in a complex titanium hexaecho in solution as it is extensively hydrolyzed. Another case is vanadium in +3 oxidation state. A vanadium echo complex is susceptible to aerial oxidation forming VO2 plus. Chromium hexaecho complex exists in solution as well as in crystalline salt and is highly acidic. Chromium in 6 oxidation state have configuration 3D0 in aqueous medium, are chromate ion, yellow in color, and dichromate in orange color. There are more examples. I've chosen few here for you. We have reached the end of this video. You can learn more about other such properties and topics in my upcoming video. Thank you for watching, and if you like my content, please hit the subscribe button.